Good morning, everyone. We're on lesson 104 today, and there's quite a bit of vocabulary in here. I need you to look at pages 429 and 430 so that you'll understand what the vocabulary is talking about. It talks about counting numbers, which we know start with 1, because if you started counting your steps, you wouldn't start counting with 0. You'd start with 1. So that's 1, 2, 3, and so on and so on. The difference between whole numbers and counting numbers is that whole numbers include 0, where counting numbers does not. And then integers are all of the whole numbers and their opposites. So -3, -2, -1, 0, 1, 2, 3, and so on and so on and so on. All right. Down at the bottom in bold black print it says, we say that a number that can be written as a fraction of integers is a rational number. So anything that you can write as a fraction is a rational number. So if I have 2, that's a rational number because it can be written as 2 over 1. 1/2 is a rational number because it's a fraction of 2 integers. So anything that can be written as a fraction is called a rational number. Okay, so now this first one gives us this number 0.00314, and we're supposed to show that it's a rational number by writing it as a fraction of integers. All right, so the easiest way to do this really is to count over how many places we'd have to move this. So 1, 2, 3, 4, 5. So if we multiply this by 10 to the 5th, it's going to move that decimal all the way to the end. But I can't just multiply by 10 to the 5th and say, number, you're ugly the way you are. I'm going to change you magically into a whole number. If I multiply by 10 to the 5th, I also have to divide by 10 to the 5th. All right? So when we multiply by that, it moves it over the 5 places. So it becomes 314 in the numerator. And then 10 to the 5th is simply 1 with 5 zeros. So it's 314 over 100,000. Okay, and then the next one, if I can see this all right, has, let's see, 1, 2, 3, 4, 5 zeros. And then 6, 2, 3. And it wants us to write that as a ratio of 2 integers, or write it as a fraction. So how many places are we going to have to move this over? 1, 2, 3, 4, 5, 6, 7, 8. So we need to multiply by 10 to the 8th, which means we have to also divide by 10 to the 8th. So when we do that, this becomes 623, and the denominator becomes 1 with 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So 623 over 100 million. All right, so that's pretty easy. The next one is a repeating decimal. And if we have a repeating decimal, we can always show that it is a rational number. And that's what we're going to be doing in the next few examples. So we have show that 0.01623 with a bar over the 2 and the 3. Make sure that you can always tell where the bar is. It makes a big difference in your answer. So there's 2 digits under that repeating bar. In the decimal system, 1 digit equates to 10, 2 digits to 100, 3 digits, 1,000, and so on and so on. So I have 2 digits under this repeating bar. Okay? I'm going to call this number right here n, because it is the original number. And then because there are 2 digits under this repeating bar, I'm going to multiply this entire equation by 100. The 2 digits tells me that it's got to be multiplied by 100. Now, when you multiply by 100, remember, you move the decimal over 2 places. Okay, so this is going to be 100n. This decimal is going to move to right here. So we have to line up the decimal very carefully. the new equation becomes 1.623. And that little repeating bar means I can write it as many times as I need to, right? It just keeps repeating. Okay. Now, subtract these two equations. So 100n minus 1n is 99n. Now we're going to very carefully subtract these. See the way we have this lined up? The repeating bars just cancel out, don't they? Now we'll subtract what's left. So 13 minus 6 is 7. 1 minus 1 is 0. 6 minus 0 is 6. And 1 minus nothing is 1. And then to get the n by itself, we divide both sides by 99. Okay, now it says the ratio of two integers. The way we have it written right now, this is not an integer. So we have to get the decimal to the end of that number, which means we need to move it over 3 places. So we're going to multiply by 10 to the third, but we also have to divide by 10 to the third. So the actual number is going to be, move this over, the 1607. And down here, this will be 99 with 3 zeros. And there you have it. So actually, if you take your calculator and divide this by this, you should get 0.0162323232323 as long as your calculator will print it out. So we just proved that this repeating number right here is actually equal to this ratio of two integers. Okay, so let's try another one. Show that, this is 104.4, show that 1.0031543 in the repeating bar over the 543 is a rational number by writing it as a quotient of two integers. All right, so first thing we do is we call this n. It's the original number. The second thing we do is look at how many digits there are under that repeating bar. So how many digits do we have right here? 3. Can you tell me how much does 3 places in the decimal system equate to? 2 is 100, 1 is 10, so 3 is 1,000. So we're going to multiply this entire equation by 1,000. And when we multiply by 1,000, remember it moves the decimal over 1, 2, 3 places. So the new equation will be 1,003, line up the decimal, 1,543, and then 543 as many times as we need it, because it is a repeating decimal. All right, now this time it's 1,000 minus 1, which is 999n. And over here, the 543's will cancel. So we have 3 minus 1 is 2, 4 minus 3 is 1, 5 minus 0 is 5, 1 minus 0 is 1, 3 minus 1 is 2, 0, 0, 1. And to get n by itself, we need to divide everything by 999. And the only problem with this is that we can't leave this decimal in here and have that a ratio of integers. We have to get the decimal to the end. So that's 1, 2, 3, 4. We need to multiply by 10 to the 4th and also divide by 10 to the 4th. So n will be equal to 10021512 times, divided by 999 times 10 to the 4th means put 1, 2, 3, 4 zeros. So there we have it. So this repeating number is actually this written as a ratio of two integers. It's really pretty cool. Okay, one more. And I don't know why, they save the easiest one for last. They don't usually do that. 104.5 says, show that 13.012, and the only thing that's repeating is the 2, is a rational number by writing it as a fraction of integers. All right, so this is n. And there's how many digits under that repeating bar? There's only 1. And 1 in the decimal system equates to what? 10. So multiply this whole equation by 10. So we'll have 10, I'm going to just block that off. 10n equals, when we multiply by 10, it just moves the decimal over one place. So this will be 130.122, and write the 2 as many times as we need it. Okay, so this time 10 minus 1 is 9n. This last 2 cancels out. 2 minus 1 is 1. 1 minus 0 is 1. Bring the decimal straight down. 10 minus 3 is 7. 2 minus 1 is 1. And 1. And then divide both sides by 9. And we got to get rid of the decimal. So that means we have to move it over 2 places. So we multiply by 10 to the second over 10 to the second. We get n equals 11711 over 9 with 2 zeros. And you never have to reduce these, you guys. Just leave them in that format. You do not have to reduce them. Okay, that's today's lesson. Thank